Namaste students, welcome back to Rama Teaches You. Today we are going to do the third video of class 11 topic, forces, motion in a, no, not motion in a plane. What was it? Uh, laws of motion. Laws of motion, class 11 English video. Okay, so let's start. So we're going to start with, common forces in mechanics and circular motion. Okay, what are the forces that we're going to discuss today? Let's see. So in mechanics, we encounter several kinds of forces. Number one, the gravitational force. The force of attraction that arises between two bodies having definite masses is called a gravitational force, right? The force between two masses is called the gravitational force. We know that. Okay, it is a non-contact force. That is the reason why whenever we drop something, it falls to the ground because of Earth's gravity. Next, contact forces. It is a force that is applied by objects in contact with each other. Some of the contact forces are, you have the frictional force. Frictional force only arises when there is an actual contact between two objects. If there is a movement, if there is a relative movement with contact between two objects, we say that it is a non-contact force. Clear? Next, the normal force. It is a type of contact force which is normal to the surface in contact. You can only experience normal force if an object is in contact with another force. The buoyant force. Buoyant force is what? The force experienced by a fluid in which the object is kept. The upward force experienced by the object is called the buoyant force. And the buoyant force equals what? The buoyant force usually equals the weight of the object, right? Weight of the liquid displaced. So the buoyant force is given as the weight of the liquid displayed. Okay. Next, spring force. The force generated in the spring when it is either elongated or compressed for a small displacement. It is expressed as force is equal to kx, where k is known as the spring constant. We are going to learn more about this when we learn the last two topics of this chapter. Okay, in the last two topics of the book, not this chapter, we have the oscillations and the waves. In oscillations chapter, we will learn more about the spring. Okay, I think that's the this thing. Now, tension. When a body of mass m is fastened with a string, then the weight of the body acts downwards while a force acts just opposite to the downward force for balancing the downward force. So, in simple words, we can say that tension is the force that is basically produced on a spring on a string under which is basically applied with a weight. Let's see. I'll show you this. So let us imagine that this is the ceiling and this is a string. This is a mass m. The mass m has a downward force of mg. So the upward force that is experienced by the string is called tension. Okay, tension is the force that basically goes through the string. Now, when a body of mass m is fastened with a string, then the weight of the body acts downwards, while a force acts just opposite to the downward force for balancing the downward force. This force is called tension. Understood? This is what we call tension. F is equal to mg. Okay, F is equal to mg, T is equal to mg. Now, the gravitational force is the only non-contact force that we use in mechanics. Okay, in mechanics, we are not going to discuss about the electrostatic force or the magnetic force. Understood? Those are part of the 12th class chapters. Understood? Okay. So if the rope is not light, we will consider its weight as well. The weight of the rope is also to be considered. Next, usually when we have rope based questions, they will separately tell us that the weight of the rope is weightless, the rope is massless, or the rope is weightless. In that case, all you have to do is consider the weight of the object onto which the string is attached. Understood? Only that object's mass has to be considered, object's weight has to be considered. Okay, now the most important topic that we have in this chapter is friction. Okay, that is the only contact force that we are going to learn. Okay, frictional force. When a body moves or tends to move over the surface of another body, a force comes into play, which acts parallel to the surface of the contact and opposes the relative motion. This opposing force is called the frictional force. Frictional force always applies on an object in the opposite direction of the motion of the object. It will always act opposite to the motion of the object if it is in contact with the surface. Explanation. Consider a wooden block placed on a horizontal surface and give it a gentle push. The block slides through a small distance and comes to rest. Okay, now, then, according to Newton's second law, a retarding force must be acting on the object. Retarding force must be acting on the object, right? So, a retarding force is able to slow the object down. We applied a force. When we applied a force onto the object, if there were no frictional force, then the object will continue to move forever. But the object eventually stops its movement. This is due to the frictional force. Okay. The retarding force or the opposing force is called the friction or frictional force. Okay, this is the contact surface. This is the direction of motion. Therefore, this area, this becomes the frictional force. The frictional force acting in this direction. If the motion is in the left direction, then the friction will act in the right direction. As shown in the above figure, the force of friction always acts tangential to the surface in contact and is a direction opposite to the direction of the relative motion of the body. Now, we have already discussed this friction in ninth class. Ninth class, we had a small topic where we were learning about friction, right? Now, in 11th class, we have to go much more into detail. Now, what are the various types of friction that we have? Internal friction and external friction. It arises on the account of the relative motion between two layers of a liquid. Internal friction is also refers to as the viscosity of the liquid. Okay, now in a fluid, basically the particles of a fluid do not all move in the same velocity. Okay, they basically move depending on which layer they are. The topmost layer of the fluid will flow the fastest, whereas the bottommost layer of the fluid will flow the slowest. Okay, so there is friction between multiple layers of the fluid. We are going to learn more about this in fluid dynamics, the chapter that we will learn like 3 4 chapters after this. Okay, so that is known as internal friction. The friction that is happening inside the fluid itself is called fluid friction or viscosity of a liquid. Now, what is external friction? It arises when two bodies in contact with each other try to move, or there is an actual relative motion between the two bodies. This external friction is also called contact friction. Okay, so friction between two surfaces that are in contact with each other and also in relative motion with each other is called what? Is called external friction. Did you understand this? Okay, they not only have to be in contact, but there should be a relative motion between these two surfaces. If and only if there is a relative motion between these two surfaces, then and only then the friction will arise. Clear? Which one? You mean internal and external friction? Yeah. So in internal friction, what happens? Have you ever seen honey flow? Okay, you take a small plate, you put a drop of honey on top of it, and you observe its motion. The topmost layer of the honey will flow the fastest, whereas the bottommost layer of the honey flows the slowest. Okay, why is it happening? Because the bottommost layer of the fluid is experiencing the most of the weight of the fluid, right? Whereas the topmost layer hardly experiences any weight because it is the top. Okay, so due to which what happens? It has the ability to flow faster. It has an ability to flow faster. So basically, if this is a liquid, if it is flowing like this, the topmost layer will flow faster and will flow like this. Will flow like this. Next time, observe a small drop of honey flowing through a plate. You will see this. The upper layer is moving faster, the lower layer is moving slower. There is different layers are having different speeds. Why is it happening? Why do different layers have different speeds? Different layers have different speeds because they are having different frictions, and that is called viscosity. That is the property of a fluid. The property of a fluid which produces opposing motion of an object inside the fluid is called viscosity. Understood? It is called viscosity. Okay, and the opposing force that is produced is called the viscous drag. Okay, we will learn more about this in the coming chapters. Okay, but right now we are going to focus on external friction. External friction only occurs when there is a contact between two objects and there is a relative motion between the two objects. Is your doubt a little bit clear, Drupad? Is your doubt clear? So there are two types of external friction. Okay, further external friction are of three types. No, sorry, not two types, three types. One, you have the static friction. Let us consider a wooden block placed over a horizontal table. Apply a small force F on it as shown in the following figure. The block does not move, right? If you have just placed an object like this and I'm just trying to push it like this, okay, the object does not move because the static friction, the friction that is being acted on upon the object by its weight and the surface is more, so I have to use more force. I have to use more force. The force of friction Fs comes into action when the balanced forces, that is the applied force and the friction, become equal to each other. Okay, when the applied force and the frictional force are equal to each other, that type of friction is called static friction. Thus, force of friction which comes into play between two bodies before one body actually starts moving over the other is called static friction, and it is denoted as Fs, small f s. Therefore, static friction opposes the impending motion, that is, the motion that would take place under the applied force. If friction were absent, the static friction does not exist by itself. When there is no applied force, there is no static friction. It is a self adjusting force. So, friction is a very strange type of force. It only occurs if there is a external force being applied. If there is no force being applied, then the friction becomes zero. Static friction is what? Static friction is a type of friction in which if the force that is being applied onto the object is less than the frictional force, if the force that is being applied onto the object does not make the object move, then the friction produced on the other end is called static friction. Okay, now limiting friction. As we increase the applied force on the block, static friction Fs also increases to balance the applied force and the block does not move. Once the applied force is increased beyond a certain limit, the block just begins to move. At this stage, the static friction is maximum. Okay, before the object actually starts to move, before the object actually starts to move, the friction that is being produced by the surface and the body is the maximum. Okay, once it starts to move, the static friction disappears. Okay, so hence maximum force of static friction which comes into play when an object just starts moving over the surface of another body is called the limiting friction. That is, Fs should be less than or equal to Fs max. There are four laws of limiting friction, such as the value of limiting friction depends upon the nature of the two surfaces in contact and their state of roughness. Okay, so why does friction occur in the first place? Okay, when we look at an object, it may seem very smooth. When we look at an object, it may seem very smooth. But if we look at it at a microscopic level, there are irregularities present on the surface. The surface is no longer smooth. So when you place one object on top of another object at a microscopic level, The irregularities of both the objects try to what? Try to mangle with each other. They interlock their irregularities, and then when we try to move one object on the surface of another object, what ends up happening is that the friction, the force required to overcome this interlocking that we see, that is what friction is called. The force required to interlock, the force required to overcome this interlock is called friction. Okay, the value of the limiting friction depends on the nature of the two surfaces in contact and the state of roughness. The force of limiting friction is tangential, parallel to the surfaces in contact, and acts opposite to the direction in which the body would start moving on application of force. The frictional force will always be parallel to the surface. The frictional force will always be parallel to the surface, no matter whether the actual force is parallel to the surface or not. If you apply a force at an angle, the frictional force will still be parallel to the surface. Understood? So, even if you have a surface like this, you have a block like this, you are applying a force like this, the frictional force is always going to be parallel to the surface. The value of limiting friction is independent of the area in contact so long as the normal reaction remains the same. So it does not depend on the area. This is an assertion reasoning based question. Okay, it does not depend on the area, how much area is being under contact. It does not depend on. Next. So the value of limiting friction, Fs max, between two given surfaces is directly proportional to the normal reaction force between the two surfaces. Okay, so what is the normal reaction force? It is a force which is balancing the mass, which is balancing the weight of the object. Okay, the force which is balancing the weight of the object is called the normal force. And the normal force will always be what? The normal force will always be perpendicular to the surface. No matter how the surface is aligned, whether it is an incline or a decline, or whether it is parallel to the surface, the normal force will always be perpendicular to the surface. Understood? It will always be perpendicular to the surface. So we can say that the static friction Fs should be directly proportional to the normal reaction, whereas to remove the constant of proportionality, we use a term called mu of s. This is known as the coefficient. This is known as the coefficient of static friction. Okay, this is known as the coefficient of static friction. So this is a free body diagram of an object placed on top of a surface. You are applying a force in this direction. You are applying a force in this direction. Frictional force is being applied in this direction. You have weight downwards and you have your normal reaction force upwards. Understood? So if if your body is if the surface is inclined to the actual surface of earth, that is basically if the surface is like this, the angle is 0, then we can say that the weight will be equal to the normal reaction force. Why did I say this? Why did I say this? See, basically if you have a surface like this, okay, the weight will be balancing out the reaction force. Mg will balance out the reaction force. But if you have a surface like this and an object is placed like this, the weight will be like this. The weight will be still vertically downwards, but the normal reaction force will be like this. Okay, it will still be perpendicular. It will be perpendicular to the surface again. Okay, did you understand this logic? Okay. The reaction force will always be perpendicular to the surface on which the object is placed. Next. Okay. Now, mu s will be equal to what? Mu s will be equal. We know that Fs max, the limiting friction, should always be equal to the normal reactionary force times the coefficient of static friction. So the coefficient of static friction becomes equal to what? Fs max, or the limiting friction about divided by the normal reaction. Okay, normal reaction. The proportionality constant mu s is called the coefficient of static friction. It is defined as the ratio of limiting friction to the normal reaction. Now, Drupad, what would be the SI unit of coefficient of static friction? What would be the SI unit of coefficient of static friction? It won't have a coefficient. Exactly. It won't have a coefficient because in the top also you are having force, in the bottom also you are having force. Both the forces cancel each other out. So you'll be left with what? You will be left with no units. Okay. A horizontal force of example number one. A horizontal force of 980 newtons is required to slide a sledge weighing 1200 kilogram force. What is kilogram force, Drupad? What is kilogram force? Kg force? 1 kg force is how much? 9.8 newtons. So the sledge weighing 1200 kilogram force over a flat surface. Calculate the coefficient of friction. Okay, we have to calculate the coefficient of friction. So mu s is equal to what? Mu s is equal to your maximum static friction. Is wait, horizontal required to slide a sledge. Oh, they have given us, wait, they have given us the applied force. Okay, that is 980 newtons is required to slide a sledge weighing 1200 kilogram feet. So basically they've given us the weight. Weight is equal to 1200 kilogram force, or simply 1200 multiplied by 9.8. Okay, over a flat surface. Sliding means what? This much amount of force, 980 newtons, is required to just make the object start moving. So this force also becomes equal to the Fs max. Did you understand the logic? So how an applied force is becoming equal to the maximum static friction? Right? The object is just starting to move. The object is just starting to move. Therefore, the applied force becomes equal to the limiting friction. Understood? Limiting static friction. So mu of s is equal to how much? It will be 1200 multiplied by, no, wait, 980 upon 1200 multiplied by 9.8. So this becomes equal to 100. This and this gets cancelled. So mu of s becomes equal to 1 upon 12 is equal to, what is the value of 1 upon 12? 0.083. Okay, clear? Okay. Uh, where's my calculator? I need the calculator once again. Yeah, 0.083. That's correct. Next one. A block, example number two. A block of mass 2 kg is placed on the floor. The coefficient of static friction is 0.4. A force of 2.5 newtons is applied on the block as shown in figure. Okay, they have given us the mass. The coefficient of static friction mu of s is also given, and a force of 2.5 newtons is applied on the block as shown in figure. Calculate the force of friction between the block and the floor. Okay, the 2.5 newtons is being applied. Okay, so F is also given. Applied force is also given. So we know that the mass is 2.5, sorry, 2 kgs, no 2.5. The mass is 2 kg. Coefficient of static friction is 0.4. Applied forces 2.5 newtons. Okay. Now, so what should be the normal reaction be force be equal to? The normal reaction force is equal to how much? What is the formula? Normal reaction force. What is the normal reaction force equal to? Mg. Okay. The normal reaction force is equal to mg. So I'm going to take the value of g as 10. So R becomes equal to 2 into 10 is equal to 20 newtons. Now, frictional force is equal to how much? 0.4 multiplied by the coefficient of static friction, mu of s multiplied by normal reaction. So 0.4 multiplied by 20. So 248 newtons. The frictional force becomes equal to 8 newtons. They have used 9.8, so they are getting 7.84, but otherwise you will get 8 newtons of friction. Okay, 8 newtons of static friction will be applied. Understood? Okay, now how much is the applied force? 2.5 newtons. The applied force is 2.5 newtons, but the limiting frictional force is how much? 8 newtons. So will this 2.5 newton force be able to move this object? No, it won't be able to move this object because the applied force is less than the frictional force. If you want to move the object with a constant velocity, at least the least that you have to do is apply the frictional force, which is equal to the limiting force. Okay, limiting frictional force has to be applied. Next, the angle of friction. Okay, the angle of friction may be defined as the angle which can may be defined as the angle which the resultant of the limiting friction and the normal reaction make with the normal reaction. Okay, so the angle between the apply is the angle which the resultant of the limiting friction, resultant is this value, resultant of the limiting friction makes with the normal reaction force. One second. So what do we have to do? We have to figure out the angle between the resultant, okay, the resultant of the limiting friction and the normal reaction makes with the and the normal reaction with the normal reaction. Okay, the resultant of the friction and the normal reaction with the normal reaction, this is the angle that we're talking about. Now, in the given figure, OA represents the normal reaction R, which balances the weight of the body. The weight of the body is here, the normal reaction is here. Okay. Now, P is the applied force and OC is the resultant limiting friction and normal reaction. Okay. So, OC, हाँ वो बाद में कर दूंगा टिक. Okay. So OB represents the limiting friction, P is the applied force, and OC is the resultant of the limiting friction and the normal reaction. The angle theta between the normal reaction R and the resultant OC is the angle of friction. Okay, so what is the angle of friction? The angle between the normal reaction and the resultant and the friction. Okay, this is the resultant of the normal reaction and the friction, and this is the normal reaction. So the angle between these two becomes the angle of friction. Okay, the value of angle of friction depends on the nature of the material in contact and the nature of the surface, smoothness or roughness. Okay, so relation between angle of friction theta and the coefficient of friction mu in triangle AOC. Okay, now I'm just going to redraw this here. So you have a surface like this, you have a block like this is the mg and this is the r. Okay, this is mg and this is the r. So this is the applied force in this direction. This is applied force. Okay, let's call it just F. Okay, and this is what? The static friction. Okay, this is the static friction. So this is the normal reaction, this is the static friction. So Drupal, if these two are like this, then can I draw this? This will become my what? The resultant of the static friction and the normal reaction. So this is F resultant. Okay, the angle between the F resultant and the normal reaction becomes theta. Okay, now in triangle AOC, let's actually name it. You have A, you have O, you have C, you have B, and you have P. Okay, so in triangle AOC, what is the value of tan theta? tan theta is equal to opposite side upon adjacent side, right? So tan theta is equal to what? Opposite side is how much? Fs upon adjacent side is r, right? So Fs upon r, but we know the value of Fs upon r is how much? Fs upon r is what? Is equal to the coefficient of static friction. So basically we can say that tan theta is equal to what? Mu of s. Direct relation we will get. Okay, the trigonometric value of tan theta, the trigonometric value of tan theta becomes equal to the coefficient of static friction. Is there any doubt here? What is the value of theta? Theta is the angle between the resultant of the reaction and the static friction with the value of reaction. So this is the angle. Understood? Clear? Okay, let's move on. So tan theta becomes equal to the coefficient of static friction. Okay, so what is the value of theta? Theta becomes equal to tan inverse static friction. Okay, a force of a force of 49 newtons is just sufficient to pull a block of wood weighing 10 kgs on a normal horizontal surface. So this is what uh, 49 newtons, okay, is just sufficient to pull a block of wood weighing 10 kgs. So this will become mg is equal to 10 multiplied by 9.8 is equal to 98 newtons in this direction. Okay, so calculate the coefficient of friction and the angle of friction. Okay, so what is the coefficient of friction? So, Drupad, if the object is just starting to move, if the object is just starting to move, then the frictional force, that is the static friction, becomes equal to the applied friction, right? So the static friction F of S is also equal to 49 newtons. So if this is 98 newtons acting downwards, then the reaction force becomes equal to how much? 98 newtons. We know the value of static friction. Coefficient of static friction is equal to what? The applied friction Fs upon your normal reaction, which is R, is equal to 49 upon 98 is equal to how much? 1 upon 2. So the coefficient of static friction becomes half. Now we know that tan theta is equal to the coefficient of static friction. So theta becomes equal to tan inverse mu of s. So what is tan inverse 1 by 2? Oh, we don't know the value of tan inverse 1 by 2. So we can write it as tan inverse 1 by 2 can be written as uh, sine inverse of 1 by 2 upon cos inverse of 1 by 2, right? So tan inverse 1 by 2 can be written as sine inverse 1 by 2 upon cos inverse 1 by 2. Sine inverse 1 by 2 is how much? Pi by 6. And cos inverse 1 by 2 is how much? Pi by 3. Pi and pi gets cut off. So this 3 will go up, 6 will go down, 3 by 6. Oh, no, no, no. What am I doing? What am I doing? 3 by 6, 1 by 2. Uh, where did I go wrong? Oh, no, no, no. You can't do like this. You can't do like this. You can't do like this. Okay. So if theta becomes equal to how much? Theta becomes equal to tan inverse 0.5 equals, yeah, it's correct. So 26 degrees and 26.56 degrees. Okay, if you want to convert this into degrees and minutes, what will you do? 26 degrees, and if you want to convert this 5 6 into this thing, how much will you get? You will have to multiply this by, if you want to get, if you want to convert 26.56 degrees into 26 degrees and something something minutes, what do you do? One by 60 or multiplied by 60, Drupad? because it's in this thing in degrees. No, you have to convert the degrees into minutes. What do? You multiply it by 60, don't you? Yeah, so basically you will have 56 multiplied by 60 becomes equal to, yeah, so this will become equal to 33 minutes. Okay, and then you will have to convert that into seconds also, and this will be 33 3360 minutes. Okay, so basically if you convert that, you will get 34 minutes. 34 minutes. Okay, let's move on to the next question. The angle of response. Okay, angle of response is defined as the minimum angle of inclination of a plane with the horizontal, such that the body placed on a plane just begins to slide down the incline. Okay, so angle of response, I will actually tell you how to actually look for it. Okay, so imagine that this is an object. Okay, can you see the object? I have placed another object like this. Okay, now at what angle will the box actually start to slide? The box is not sliding. The box is not sliding. I'm slowly increasing the angle. I'm slowly increasing the angle. Yeah. So at this particular angle, what happened? The box started to move, right? The angle in which the box just starts to move. The angle in which the box just starts to move is called the angle of response. Okay, it is represented by alpha, and its value depends on the material and the nature of the surface in contact. Okay, it depends. Like basically, right now, this thing was what? This thing was plastic. So plastic has less resistance. It was coated in plastic. Now, if I use my phone, which is like a rubber case, what happens? If I use my phone, I will have a larger angle, right? This angle at this point only it starts to basically slide. Okay, so here it depends on the nature of the material and nature of the surfaces in contact. Consider a body of mass m placed on an inclined plane. The angle of inclination alpha of the inclined plane is so adjusted that the body placed on it just begins to slide. The body slowly and slowly just starts to slide, and that angle is called the angle of inclination. Did you understand this? You understood this, right, Dupal? Okay, let's move on. Thus, alpha is the angle of response, and the various forces acting on the body are what? Okay, so again, let's actually redraw this. Okay, you have an angle alpha here. This is what? This is a body of mass m. Now, the mg value will still straight be downwards. It will still be downwards. Okay, now, if this is alpha, this is 90 degrees. Drupad, what angle will this be? If this is alpha, this is 90 degrees. This becomes 90 minus alpha, right? This angle becomes 90 minus alpha. And we all know that this complete angle should be equal to 90 degrees. So if this is 90 minus alpha, then this has to become alpha, right? So this was alpha, this became 90 degrees, this became 90 minus alpha. So this angle, so basically this value, right? This value became 90 minus alpha. Sorry, this became 90 minus alpha, and this became alpha. Now, what is happening here? The object is beginning to slide downwards, right? The object is beginning to slide downwards, and there is a frictional force. The frictional force will always be parallel to the surface. So the frictional force is applying here in this direction. This is how the frictional force is getting applied. Okay, and the reaction force will always be what? The reaction force will always be perpendicular to the surface. No matter at which angle the surface, no matter at which angle the surface is, okay, the reactionary force will always be what? It will always be perpendicular to the surface. I can actually explain this to you what happens. Now, Drupad, when you are climbing a mountain, when you are climbing a mountain, Do you feel attached to the mountain, like basically like this? Drupal, if you're climbing a steep mountain like this, okay, if you are climbing a steep mountain like this, okay, now the weight that you experienced in the towards this direction, does it increase or decrease? Right? You actually feel the weight in this direction increasing. You may try to fall. Okay, you may even try to fall right in this direction. So the actual mass that is being applied downwards is not that high. You have a reactionary force like this. The reactionary force is like this. So the reactionary force actually reduces as the angle increases. Okay, so let's actually move on to this. So what was I saying? I was saying that the reactionary force is always perpendicular to the surface. Understood? The reactionary force is always perpendicular to the surface. One second. Okay. So now let's actually analyze. Thus, alpha is the angle of response of the various forces. Now, Drupad, this is mg. Okay. This value is mg. Now, can I resolve the value of mg in two different axes, the horizontal and the vertical? Now, for the surface, we always consider the horizontal axis parallel to the surface onto which the object is placed. Okay, this is not going to be the horizontal force anymore. The horizontal force is now parallel to the surface of the object. Okay, the surface onto which the object is placed, that is where the axis lie. So this becomes our vertical axis and this becomes our horizontal axis. Clear? Okay, now let's actually look at this. So you have mg right here. Okay, there is mg here. Now this mg going downwards can be split into two forces. This becomes mg cos theta. This becomes mg sine theta. And the force that is actually making the object slide downwards is what? Mg sine theta. The force that is actually keeping the object in contact with the surface is what? Mg cos theta. This mg cos theta will be equal to the reactionary force R. Okay, because these two are what? These two are a pair of forces with the same magnitude but opposite direction. So therefore, this becomes the reactionary force. This becomes the actual force with which the object is being weighed down onto the surface. And if this is mg sine theta, and then this will be Fs. Okay, the frictional force. Understood? Now, what do you observe from here? What do you observe from here? Let's see. The weight mg of the body acting vertically downwards. Okay, fine. The limiting friction Fs max is acting along the inclined plane in the upward direction, right? Because it will always be parallel to the surface. It is moving in the upward direction because the object is coming down. It is balanced. It balances the component mg sine alpha of the weight mg perpendicular to the inclined plane. Thus, Fs becomes equal to mg sine alpha. Okay, now when the object just starts to move, alpha is what? Alpha is the initiating angle, right? It is the action. What was the name of alpha? Alpha is called the angle of response. Yeah, the angle of response. Now at this angle the object is just starting to move. It is just starting to move. If when it is just starting to move, what happens? The applied force becomes equal to the frictional force. So we can write it as Fs is equal to mg sine theta, sorry, sine alpha. Fs becomes equal to mg sine alpha. This is also alpha, not theta. Okay, Fs becomes equal to mg sine alpha. Now, the normal reaction R is acting at right angles to the inclined plane in the upward direction. It is balanced by the weight mg cos alpha of the mg cos alpha of the weight mg perpendicular to the inclined plane. Thus, the reactionary force R becomes equal to mg cos alpha. Is there any doubt here? The friction. Who is causing the friction? Since there is no external force being applied, who is causing the friction? The horizontal component of the weight. The horizontal component of the weight is basically producing, it is producing the applied force. Okay, in the forward direction, the force that is actually allowing the object to move forward. Okay, this should be balanced by what? This should be balanced by the frictional force. Similarly, the reactionary force is balanced by the vertical component of mass, is balanced by the vertical component of mass called mg cos alpha. One thing that you have to remember is that cos and sine do not always have to be with horizontal and vertical. Okay, depending on the angle, you have to choose cos and sine. Understood? Did you understand the diagram? Did you understand the relation? Okay, let's move on. Now, so dividing the equation 1 by equation 2. This is equation 1, right? Fs is equal to mg sin alpha, r is equal to mg cos alpha. What do you get? Fs upon r should be equal to mg sin alpha upon mg cos alpha. Mg and mg gets cut off. So Fs upon r becomes equal to tan alpha. So Fs upon R becomes equal to how much? Tan alpha. The coefficient of static friction is equal to the tangent of the angle of response. Understood? So what is the coefficient of static friction? Coefficient of static friction is defined as the ratio of the static friction upon the normal reactionary force. Now, when the object is placed in an inclined plane with an angle alpha called the angle of response, then the angle, the static friction becomes equals to tan alpha. Okay, so static friction becomes equal to tan alpha. Understood? Now, tan theta is equal to tan alpha. Now, at the angle of response, what do you have to understand? The angle of response becomes the resultant angle between the resultant force. What were the two forces that we made a resultant of? The frictional force and the reaction force. And the resultant force and the reaction for the resultant force and the reaction force is where we have the frictional angle, the angle of friction. Okay, so at angle alpha, they both become equal. Understood? At angle alpha, both the frictions, both the forces become equal. Okay, now the kinetic friction. When we increase the applied force slightly beyond the limiting friction, the actual motion starts and the force of friction decreases. This means that the applied force is now greater than the force of the limiting friction. The force of friction at this stage is called the kinetic friction or dynamic friction. Okay, we call it the kinetic or the dynamic friction. Why do we call them kinetic? Because kinetic basically means movement, right? Now, the friction that is produced when the object is in motion is known as dynamic friction. Okay, next. So, which is actually a little bit less than the value of the limiting friction. I'll tell you why this happens. Okay, now when the object is at rest, I have already told you that both the surfaces at a microscopic level, they have irregularities. Now the irregularities of the two surfaces, when placed on top of each other, they interlock each other, and basically when they interlock each other, you have to apply a force. You have to apply a force to overcome this interlock. Okay, but when the object actually starts to move, okay, when it starts to move, what happens? The two surfaces do not have enough time for the interlocking to happen properly. Okay, the interlocking requires time. The interlocking requires time between the two surfaces. Okay, but when the object is in motion, what is happening? The time required for interlocking, proper interlocking, is not provided. Therefore, what happens? The dynamic friction or the kinetic friction basically has a value less than the limiting friction. Okay, because we are trying to avoid the proper interlocking between the surfaces, the kinetic friction becomes less than the limiting friction. Understood? Clear? Any doubts? Okay, let's move on. Hence, the kinetic friction or the dynamic friction is the opposing force that comes into play when the object is actually moving. When the object is actually moving over the surface of another body. Thus, the kinetic friction opposes the relative motion. The kinetic friction opposes the relative motion. There are four laws of kinetic friction. They are as follows. The kinetic friction opposes the relative motion and has a constant value which depends on the nature of the two surfaces. Okay, once you have started moving, then the friction is not going to change much. Okay, it's not going to change much, it's going to remain the same. Okay, now the value of the kinetic friction Fk is independent of the area of contact, similar to static friction. It is basically uniform. Okay, it does not depend on the area of the surfaces which are in contact with each other, as long as the normal reaction force remains the same. If the normal reaction force changes, then area comes into play. Otherwise, if the normal reaction force is not changing, if there is no problem with the normal force, if the normal force is uniform over all the object's area, then what happens? It becomes independent of area. The kinetic friction does not depend on velocity. The value of kinetic friction Fk is directly proportional to the normal reaction R between the two surfaces. Similar to that of static friction, the kinetic friction also is directly proportional to the normal reaction force. Now, to remove this proportionality, what do? We use the coefficient of kinetic friction. Okay, the kinetic friction also has the same formula. The friction in motion upon the normal reaction force. Okay, that is the value of kinetic friction, and similar to that of static friction, it also does not have any unit because it is simply a ratio between two forces. Since it's a ratio between two forces, this also does not have any unit. Understood? Clear? Any doubts till now? You have a doubt? Oh yes, we call it fluid drag. It's called the drag. Air is a fluid. Air, water, and anything that can flow. What is a fluid? Anything that can flow is a fluid. Solid does not flow. Therefore, solid is a solid. It is different. Whereas air and liquids, gases and liquids, both can flow from one place to another. That is why they are known as fluids. Fluids have fluid drag. Okay, now it is easy for us to understand. Drupad, in the car, when your dad is driving your car really fast, if you place your hand like this, then you have less area of contact, so your hand basically pierces through the air. But as soon as you keep your hand like this, what happens? Your hand goes back. Why is it happening? It is happening because of the fluid drag, right? The parachute is able to work because of fluid drag. Okay, when a person jumps out of the plane, and when he deploys the basic parachute, what happens? The air gets trapped in the parachute, due to which what happens? It slows down the motion. Air also has a resistance, but that is called drag. It is a different form of friction. Okay, we call it drag. That also will be studied in the fluid dynamics chapter. Okay, we'll study that also in the fluid dynamics chapter. Any doubts here? Clear, right? Oh, do you have a doubt? Okay, fine. Thus, we can say that the dynamic friction will always be less than static friction. Maximum, no, not static friction. Okay, the dynamic friction will always be less than the maximum limiting friction. Okay, static friction can have values from 0 all the way to the limiting friction. Drupad, there is an MCQ or an assertion reasoning based question here. Okay, so we can say that a static friction can have zero friction also. If no force is being applied, then the static friction is zero. If the object just starts to move, then it has the maximum amount. So basically, static friction can have values from 0 to Fs max. Okay, but when we are arranging like this can be said that the dynamic friction will always be less than the maximum static friction or the limiting friction. Or you just put them in the values. Mu of K R should be less than mu of S R. Therefore, mu of K, the coefficient of dynamic friction, will always be less than the coefficient of static friction. Understood? The coefficient of dynamic friction will always be less than the coefficient of static friction. A hockey puck is given an initial speed of 20 meters per second on a frozen pond as shown in figure. The puck remains on the ice and slides 120 meters before coming to rest. Determine the coefficient of kinetic friction before the puck and the ice. 1 second. So the puck remains on the ice and slides 120 meters before coming to rest. Determine the coefficient of kinetic friction between the puck and the ice. Okay, so let's actually figure out what all they have given us. VUASTFM. Okay, so a hockey puck is given an initial speed of 20 meters per second. U is equal to 20 meters per second. On a frozen pond as shown in figure, the puck remains on the ice and slides 120 meters before coming to rest. So S is 120 meters. Final velocity is 0. Okay, determine the coefficient of kinetic friction between the puck and the ice. Okay. Why didn't they give it the mass? The coefficient of kinetic friction. Okay. Anyways, let the mass be m. So what is the deceleration going to be, Drupad? Yeah, exactly. V square minus u square is equal to 2as. So v square is 0. So minus u squared is equal to 2as. Therefore, u squared, no, minus 400 is equal to 2 multiplied by a multiplied by s is 120. So this and this becomes 200. 0 and 0 gets cut off. So acceleration is equal to minus 20 upon 12 is equal to minus 10 upon 6 is equal to minus 5 upon 3 meters per second square. Okay, so we have figured out the deceleration. Okay, now can I say that a hockey puck uh, I'm missing something. Determine the coefficient of kinetic friction. Determine the coefficient of kinetic friction. So should the applied force be equal to friction? That is why it stopped. I think that should be it. So the force required to stop the puck is equal to the dynamic friction. So I can write it as m multiplied by minus 5.3. Okay, newtons. So this is called this is what? This is the, what do you say? This is the frictional force. F kinetic. Okay. Now, what is the normal reaction going to be? Um, the normal reaction should be equal to mg. Okay, so should be equal to m multiplied by 10. So 10m is equal to 10m newtons. Okay, so we know that mu kinetic is equal to f of k upon r should be equal to minus 5 upon 3 m upon m multiplied by 10. So what happens? This and this gets cut off. So minus 5 upon, no, no, we have to use the magnitude, right? There is no minus here then. Uh, so it will be 5 upon 3 into 10, 2 is equal to 1 upon 6. What is the value of 1 upon 6 coming out to be? 1 divided by 6, 0.167. 0.167. Let's see, actually see if it's correct or not. I think I made a mistake. No, 0.167 or 0.17. Okay, it's correct. Understood. So what did we do? We first calculated the deceleration. The deceleration was question mark. So we first calculated the value of deceleration, and then we figured out the actual force. The force which is required to stop the puck should be equal to the frictional force. The force required to stop the puck should be equal to the frictional force. Now, so frictional force is equal to mass times acceleration. Okay, so mass times minus 3 by 5 by 3 newtons. So R is equal to mg is equal to 10m. Mu of k is equal to the coefficient, the kinetic friction upon the normal reaction. You will get 1.6. Okay, so mu of k will become equal to 1.67. Is there a doubt here? Doubt? Do you have a doubt? Okay, let's move on. Okay. A block P of mass 4 kg is placed on another block Q of mass 5 kg, and the block Q rests on a smooth horizontal table. For sliding block P on Q, horizontal force of 12 newtons is required to be applied on P. How much maximum force can applied on Q so that both P and Q move together? Also find out the acceleration produced by this force. Okay, once again, a block of mass P is 4 kg. Okay, this is 4 kg and this is 5 kg. Okay. And the block Q rests on a horizontal table. For sliding block P on Q, this is P, this is Q. P on Q, horizontal force of 12 newtons is required to be applied on P. Okay, so this is what? This is 12 newtons just to produce the force, just to make it move. How much maximum force can be applied on Q so that both P and Q move together? Okay, it's a smooth surface, right? Hmm. So on a horizontal, here M1 is 4 kgs and M2 is 5 kgs. Force applied on the block is 12 newtons. Okay. The force must be equal to the kinetic friction applied by P on Q. Why kinetic? One second. So they're saying that a maximum of 12 newtons, a maximum of 12 newtons when applied on the block P, it starts to slide on Q. So 12 newtons becomes equal to static friction max. maximum, it becomes equal to maximum static friction. Okay, now what is the acceleration of P? What is the acceleration of P at 12 newtons? What is the acceleration of P at 12 newtons? So we know that the force on P should be equal to ma. Therefore, acceleration on A is equal to force on P upon M is equal to force on P is how much? 12 upon M is how much? 4 is equal to 3 meters per second squared. Okay. Now, if you keep on applying 12 newtons, if you keep on applying 12 newtons, the block will simply just start to slide. It will not slide. It will simply just start to slide. So basically, if you are putting an acceleration of A is equal to 3 meters per second onto the block P, what will end up happening? If you apply an acceleration of 3 meters per second square on the block P, what will end up happening? This block will not move. This block will not move, but this whole thing will start to move. Okay, this whole thing will start to move. So the acceleration is 3 meters per second square. Now imagine this. What is the overall mass of the system? The overall mass of the system is equal to how much? The mass of P plus the mass of Q is equal to 4 plus 9, 4 plus is equal to 4 plus 5 is equal to 9 newtons. Sorry, 9. What am I writing? 4 plus 5 is equal to 9 kgs. Okay. Now, what is the maximum force that can be applied onto the system? The maximum force that can be applied onto the system is how much? The maximum force that can be applied is how much? 9 multiplied by force is equal to mass times acceleration max is equal to mass is 9 multiplied by acceleration maximum is how much? Acceleration maximum is 3 meters per second squared. Okay. Force is equal to mass times max. So you will get how much? 27 newtons. Okay. Now 27 newtons can be applied onto the system as a whole. Okay. Before the object actually starts to move. Why? Because even when you are applying 27 newtons on P, the friction is using the 3 meters per second square to stay on top of this. But this whole object is now experiencing what? This whole object is now experiencing a 1 unit system. Okay, so basically your both the masses will have to get added up. You are adding both the masses, you are getting 9 kgs. You are getting 9 kgs. Am I right? You are getting 9 kgs. Now, the acceleration that is being applied onto P is how much? 3 meters per second square. So, since there is no friction between Q and the surface, this 3 meters per second square acceleration is now being applied onto the whole system as one. Okay, so what do you get? Force is equal to mass times maximum acceleration is equal to 9 multiplied by 3 meters per second square is equal to 27 newtons. So the maximum force that can be applied on P without P actually falling off Q is how much? 27 newtons. Clear? So what did we do? What did we do? At first, we calculated the acceleration which was being acted upon on the P block by the 12 newtons. We figured out the acceleration to be how much? 3 meters per second square. Then we said that since this 4 kg block is just starting to move, therefore this 12 newtons become equals to the frictional force. The 12 newtons becomes equal to the frictional force. Acceleration is 3 meters per second. Now you take the whole system as a whole system as one. What do you get? You will get force is equal to mass times acceleration is equal to 9 multiplied by 3 meters per second square is equal to 27 meters per second, 27 newtons. Okay, and find out the maximum acceleration produced by this force. What is the maximum acceleration produced? The maximum acceleration is 3 meters per second square. I don't know what all they have done. I don't know why they calculated the mu of k value. I'll try to understand this and I'll try to explain this to you in the next video. Okay, but this method, did you understand? We are not doing by the books method, but did you understand this method? Drupad, any? Okay, next. Okay, so consider a shuffleboard cube which is being used by a cruise ship passenger to push the shuffleboard disc of mass half a kg horizontally along a deck so that the disc leaves the cube with a speed of 6 meters per second. What will be the coefficient of kinetic friction between the deck and the disc if the disc slides a distance of 10 meters before coming to rest? Okay, so what was the initial velocity? The initial velocity was 6 meters per second. The final velocity, the disc is coming to rest on the deck. So I can write it as VUASTFM. So V is coming out to be 0 meters per second. U is 6 meters per second. Acceleration is how much? We don't know the acceleration. Okay, S is how much? How much distance did this thing go? 10 meters. Okay, 10 meters. Time also we don't know. Okay, but we do know the mass. Mass is equal to 0.5 kg. That's the mass. Am I right? Okay, these are the various values. Now, first we do what? We say that the force required to stop the disc on the deck. Stop the disc on the deck is provided by the frictional force. To be more precise, the dynamic frictional force, right? The force required to bring the disc to a stop on the deck is given as the frictional force. The coefficient of the dynamic friction is the value. Yes or no? Okay, fine. So, what is the acceleration going to be? Acceleration is equal to what? Oh, we have to do the whole thing. Okay, fine. V square minus U square is equal to 2AS minus U square is equal to 2AS. Therefore, minus 36 is equal to 2 into A into 10. So, A is equal to minus 36 upon 20. So, 4 5 are 20, 4 9 minus 9 by 5 meters per second square. We have calculated the value of what? We have calculated the value of acceleration. Now we have to calculate the frictional force. Frictional force is equal to the applied force because it is coming to rest. So we can write it as force due to kinetic friction is equal to how much? Minus 9 by 5 multiplied by 0.5, right? Am I right? 0.5. So 0.5. So this becomes 10 and this value becomes 0.9. So the friction is coming out to be how much? 0.9. Okay. Now what do we have to find? Uh, what will be the coefficient of kinetic friction between the deck and the disc? Okay, so the coefficient is equal to how much? Mu of k is equal to basically uh, f of k upon r. 0. 9 upon r is how much? R is equal to mg only. So 0.5 multiplied by 10 is equal to 0.9 upon 5. So 0.9 divided by 5 is equal to 0.18. Am I correct? 0.18. Clear? It is coming out to be 0.18. Did you understand what I did? Huh? I first calculated the value of acceleration. Okay, I calculated the value of acceleration. Then I said that the force required to bring the puck to rest is equal to the frictional force. I said that, and then I used the formula. Okay, I solved the whole thing, and then I found the frictional force as 0.9 newtons. So mu of k becomes equal to what? The frictional force upon the normal reaction force. Huh? 0.9 upon 5, that is 0.18. So this becomes the coefficient of dynamic friction. That is mu of k is equal to 0.18. Okay, let's do another question. Now, this is the next topic now. Now, we will do till example number 7. Okay, after that we'll continue this in the next class. Now, types of kinetic friction. There are two types of kinetic friction. One you have is called the sliding friction, where one object literally slides over another object. Okay, this is called the sliding friction. The other is known as the rolling friction. Okay, so the force of friction that comes into play when when a body slides over the surface of another body is called sliding friction. Okay, let's see. Now, for example, when a flat block is moved over the flat surface of a table, then the opposing force acting on it is known as sliding friction. Okay, so basically, if you have a block like this block is moving in this direction, therefore the friction that is basically occurring in this direction is called the sliding friction. Laws of sliding friction. Sliding friction opposes the applied force and has a constant value depending upon the nature of the two surfaces. Do you see what is happening here? The value of friction will always remain constant when the object is moving. Okay, it will have a maximum value at the beginning of motion. Just beginning of motion, it will have the maximum value. And after that, what ends up happening? It reduces and then it becomes constant for the rest of the motion of the object. The force of sliding friction is directly proportional to the normal reaction force. We know this. The more normal reaction you have, the more will be the sliding friction. Next, the sliding frictional force is independent of the area of contact between the two surfaces as long as the normal reaction force remains the same. The sliding friction does not depend on the velocity. It does not depend on the velocity. Okay, so again, all these points are being repeated again and again and again. We did the same points for dynamic friction also, right? Dynamic friction, sliding friction is the same value. Are there any doubts in these 4 points? These 4 laws? Okay. Now, what is the acceleration of a block of a trolley system shown in figure? If the coefficient of kinetic friction between the trolley and the surface is 0.04, what is the tension in the string? Take G to be 10 meters per second square. Neglect the mass of the string. Okay, the string is massless. Okay, Drupad, see, this is what I mean by tension. Okay, so there is a weight of 3 kgs that is being basically applied downwards. So what do you have? You have a value of friction to be 30 newtons in the downward direction. You have a value of friction to be 30 newtons in the downward direction. It is also moving with an acceleration of a It is moving with an acceleration of a. Now, to balance this 30 newtons of force, there is a tension being applied on the string in this direction. Okay, so what is happening here? Right, what is the acceleration of the block? We have to find the value of a, and the trolley system shown in figure, if the coefficient of kinetic friction between the trolley and the surface is 0.04. So so 30 newtons is being applied like this. Acceleration is moving downwards. Friction should act like this. So can I simply say that T minus mg is equal to ma? Now, Drupad, the elevator story. You have a block like this. The block is going down. Okay. And the block is going down, right? The acceleration is A is downwards. This is mg. This is what? This is the tension. Okay. The same logic that we used for lifts to find the apparent weight. What did we used to say? We used to say down minus up is equal to down. So can I write this as 30 minus T is equal, so wait, mg minus T is equal to ma, because the block is moving downwards, right? So can you write this formula mg minus T is equal to ma? Okay, so mg minus T is equal to ma. So what do I have? I have the value of mg as 30 newtons. I have the value of mg as 30 newtons, so I can write it as 30 minus T is equal to 3a. Now, applying the second law of motion on the trolley. Again, Drupad, the trolley is moving, right? The trolley is moving in this direction. So the trolley is moved, since the trolley is moving in this direction, so I can say the tension minus the frictional force should be equal to ma. The tension minus the frictional force should be equal to ma. Am I right? Okay. So tension minus frictional force is equal to 20 into A. Right? This value 20. 20, this is also moving with an acceleration A. If this is moving with an acceleration A, this also has to move with an acceleration A, because the string that is being connected onto both the objects, if one accelerates with the value of A, the other also has to accelerate with a value of A. Clear? So what is the value of f of k? We can find the value of f of k is equal to how much? Mu of k multiplied by how much? The reaction force. What is the reaction force? What is the reaction force equal to, Drupad? The weight of the object is how much? What is the reaction force equal to? You can't stay silent, Drupad. Huh? It is basically R is equal to, what is the mass of this trolley? 20 kgs. 20 kgs. Then you have the acceleration due to gravity is 10. So multiplied by 10 meters per second square. So R becomes equals to 200 newtons. So 200 newtons multiplied by 0.04. 0.04 multiplied by 200 is equal to how much? 4 into 2s are 8 newtons. So f of k is equal to how much? 8 newtons. So can I write this as T minus 8 is equal to what? 3a, right? Sorry, 3 is equal to 20a. So I have two formulas, two equations. This is equation number 1 and this is equation number 2. Both the equations have two variables, t and a. Both of them have two variables, t and a. Now I have to solve these two equations. What do I get? I'll get t minus 8 is equal to 30. Therefore, t is equal to, 3a. T minus 8 is equal to 3a. Therefore, t is equal to 3a plus 8. So, if I put this in equation number 2, what do I get? 3a plus 8. What am I doing? 30 minus t is equal to 3a. T is equal to 30 minus 3a. Okay, t is equal to 30 minus 3a. I am putting the value of t in this equation. So I'll get 30 minus 3a plus, sorry, minus 8 is equal to 20a. So 30 minus 8 is 22 is equal to 20a plus 23a. A is equal to 22 upon 23. Is the answer correct? 22 upon 23? Yes. So acceleration becomes equal to 22 divided by 23 is equal to 0. A is equal to 0 0.5, sorry, 0.956. 956 meters per second square. Clear? So, what did we do? First, we used the system of particles, sorry, system of motion into two different categories. We first did it for this. Since the object was moving downwards, we said mg minus t should be equal to ma. See, this object, this was how much? Weight, the 3 kgs. This 3 kgs was going down. Okay, it was going down with an acceleration of a. So I wrote this is tension mg. Mg minus t is equal to ma. Okay, similarly, you had a trolley like this. Okay, this was tension. This is what? Dynamic friction, and the trolley is moving in this direction with an acceleration of 8. Again, I can write t minus your 20a. This is 20 kg, right? T minus 20a is equal to f of k, right? So t minus, yeah, t minus 20a is equal to f of k. Okay. No, what am I? Oh, I'm too tired today. T minus your f of k is equal to 20a. This should have been the equation. This is equation number 2. So we figured out both the equations. We've calculated the value of f of k. F of k was coming out to be 8 newtons. We put the value of f of k and then we found our answer. Understood? T and A were the variables. So by solving this question, we were able to find the answer. Okay. I'm going to do more questions like this in the next class. I'll bring another book. We will do some questions just regarding friction. Okay. So I'm going to end this video here. Okay. I'm going to end this class here, and I'll see you in the next class. Okay. So I hope you really like the video. And if you like my video, please do like, share, and subscribe. And have a nice day.